Good. Amazing. Awesome. Hi to all the students. How are you all doing? Audible? Let's start this class. For those who are watching me for the first time, you do have to make sure that you actually follow me on Unacademy app and also on my Telegram channel. So over here, guys, pay attention. As you can actually see over here, the link Luv Mehan JEE Chemistry is the link that you have to follow on Telegram. So just type this and you'll find my Telegram channel. Apart from this, there is one more Telegram channel that you have to follow, which is JEE English Unacademy. If you join these Telegram channels, you will be getting up, the notifications related to the sessions. You'll be getting up the PDFs. You will be getting up the notes of the physics and the chemistry classes. Apart from this, guys, do remember that there is one more, place that you have to come and join me. That is the Unacademy app. So if you haven't downloaded the Unacademy app, do it on your iOS and Android devices and search for Luv Mehan, LUVMEHAN, so that you can actually be upgraded. You should be updated how and when we are going to do these classes, which will enhance your preparation. A lot of students who actually are preparing for JEE, they really do not know how to start, when to start, what all preparations should we do, what all books to use, how to use those books, and a lot of things. If you are the one, then definitely follow the link, these particular links, and then ultimately be regular. Apart from this, the same one that I have also told about, do follow that as well. And apart from this, so 2021 students, if you are actually preparing for advance, there's a crash course from my end. 2022 students are also having a lot of batches. If you want the batches where every teacher is actually teaching you in English, then ultimately Spark batch is for 2023 students, Shine batch is for 2022 students, and Droppers as well. So there are a lot of batches over here which has already started in the month of September, which the dates over here, if you can see, is 1st, 8, 8, 8, 15 and 15. And do remember, guys, out of these there are a lot of batches for Droppers, and the Emerge batch, Drona, Dropper, Excel, Shine batches, a lot of India's top educators are teaching over here. So if you anyhow take Unacademy subscription for preparation, you should remember you are not restricted to any one of these batches. You can attend these classes as well. You can go into these classes, any classes that you want, and you can watch these videos and live sessions unlimited times as per your subscription is going. So do remember that. So this mic is nice. Okay. This mic is somewhat different. How is that? I don't think so. No, I didn't change any mic. Okay. So don't worry about that. Now over here, guys, I would like to tell you that ultimately, whenever we're talking about what exactly will happen when you come to Unacademy, the learning platform, you should remember you have India's best educators available over here. All the students who are actually on Plus and Iconic, they have India's best educator, and it means a lot to have India's best educators at one place. And for whom are we keeping these? For whom are we doing these things? It's only for you guys, only for your preparation. Apart from this, we have interactive live classes where students can ask their doubts real time. They get the notes and the PDFs from the teachers. All the courses are structured. Live tests and quizzes are also there. So there are regular tests which really enhance the way you actually solve these questions. You get the competitive feeling. A lot of things are over here. And yes, the personal coach, study planner, study material, expert guidelines, test analysis, personal guidance, everything is available in Iconic. And the features which I'm talking about, if whether it's the teachers, their classes, their notes, and test and quizzes, which is the core which every student should have, which every student deserves. That is the one which we are actually looking at. So do remember that. And over here, guys, pay attention. I am recommending 24 months of subscription to 2022 students, 23 students, and for 2022 students and Droppers, I recommend 12 months of subscription. It's the cheapest available out in market with the highest quality available that you get. And apart from this, guys, pay attention. The 1 month cost after discount comes out to be 34,650, and I can get you additional. This particular discount, is given to the students who actually use my code, and the code that you guys actually have to use is LUVGURU. And apart from this, boys and girls, do remember one more thing. You get additional 10% off whenever you are using this code till 17 September. This is very much limited period of. Do remember that. And now let's get started. How many of you are excited to have this particular session? And make sure that this, anyhow, this is the lecture 2, and we are going to complete the chemical kinetics in 2 more classes. Okay? And this is how we are going to do for each and every chapter. Every chapter is going to take 3 to 4 classes to cover, and ultimately you will be able to get your syllabus completed on time. So isn't this amazing? If you really like the plan, do hit the like button, share the session among your friends, and subscribe to the channel. Be regular, because you know what? Being regular is the key. No matter how much time you take to excel anything, let it be your subjects, let it be, you know, exercising, any activity, being regular, being disciplined is the most important thing to crack. Even the top AIR students, they actually, you know, are very much dedicated. They do things regularly. Do remember that. So now let's get started. Hi to Stella S and hi to Lakshmi. Welcome to the sessions. And do also let me know, have you shared the session amongst your friends? If not, do that right now. And now let's talk about the order of reactions. So in the previous class, we actually talked about how the order of the reaction is known. It's known experimentally. And now we also saw the rate law expression. What were the things? Let's do this over here. We'll do a small recap over here. So now, what was the rate law expression telling us? Rate is directly proportional to the concentration of reactant 1, concentration of reactant 2, if there are more reactants, raised per m and raised per n, where these m and n, these variables are actually known experimentally. What is the final equation? R is equals to K, concentration of reactant A, concentration of reactant B, raised per m and n, where this K is the rate constant. Correct? This is the rate constant. And apart from this, guys, do remember one thing. This m and n, if you sum it up, this gives you the order of reaction, right? This is the order of the reaction. Okay? And now, so I couldn't be regular, but you have to be. Okay? So wherever you think that, you know, things are getting in your head, if I am the one who's actually teaching you well, so you should be at least regular to my classes. So, you know, and you should always stick to one particular educator. Everybody has a different style. Everybody has a different style of mentoring. And everybody has different strategies and approaches. So if you are actually jumping between, teachers and mentors, it is never going to be helpful to you. Okay, so do remember that. Now let's talk about the zero order reaction. In the case of zero order reaction, you should remember, if you are writing R is equals to K raised per, the concentration of A raised per 0, then this is the zero order reaction. Correct? What exactly happens with the zero order reaction? Pay attention. Can I write, when A is raised to power 0, can I write R is equals to K? Because something raised to power 0, x raised to power 0 is always 1. So it's R into A is equals to K into 1. Right? So I'm writing R is equals to K, which means the rate of the reaction is constant. The rate of a zero order reaction is constant. Now pay attention. If you are going to make a graph, guys, pay attention. This is on the y-axis, you are writing the rate. On the x-axis, you write time. With time, does the rate of the reaction changes for zero order reaction? Not at all. Over here, it is always going to be constant. So this is what you have to remember. And now, this is what you have to remember. The value. What is the value over here? It's K. It's the K value that you are actually having. And it remains constant throughout the reaction if you do not change temperature. Okay? So do remember that. When the temperature being constant, rate constant does not change. Apart from this, when the rate constant is same, then you should remember, with time, the decrement in concentration of the reactant is, very much uniform. So what are we really looking at, guys? Pay attention. Whenever we have an R product, R reactant making product, R is making P. Okay? So now, whenever we at T is equals to 0, T is equals to 0, R concentration of R can be written as R naught. Correct? Concentration of R can be written as the R naught, where we are going to keep the R naught, the naught sign outside. Okay? So now guys, pay attention. Whenever we talk about at T is equals to something, T is equals to X, this R naught becomes R, whatever concentration is left. And let's say we started with 10 molar concentration. Now when we started with 10 molar concentration, after half an hour it became 8 or 7 or 5 or 2, whatever number it could be. That is the R. Okay? So now over here we will see how things are exactly happening. Okay? Now guys, pay attention. What are we really looking at? R is equals to R naught, the initial concentration that we had, right, minus the KT value. And why is that? Why minus KT? Because you should remember, guys, pay attention. Do you remember the rate is equals to the change in concentration of reactant upon change in time? Is this what we are looking at? Correct? This is what we are looking at, right? You should also remember in the case of rate, rate is equals to K, right? Now let's put K in the place of rate. We can do that, right? For the zero order reaction. Let's do that. So in the place of rate, I am putting up K. Awesome. We can do that, right? So now what am I going to write for this? Anyhow, change in time is also a time. 10, let's say if I actually started at 0 and after 10 seconds, the reaction ended. What is the delta T? 10 seconds. Delta T is also going to be the T. So now guys, pay attention. What are we really looking at? For the delta T, I am going to write T. And what should I write for the change in, concentration? It should be like, give me a second. Hello. Yes. Final minus initial. Final minus initial. This is the initial one. That's the reason I'm putting up a dot upon T. Now take the T on the LHS. It's going to become KT. Take the R naught value on the LHS. So ultimately, while doing this, you will get the same expression. How are we getting this? This derivation is important. No student, no serious student should run away from the derivations whenever it is important for JEE. So do remember this. Now what is exactly happening, boys and girls? Write two things. Rate is equals to K and rate is equals to change in concentration of reactant upon change in time. Where you can actually write K is equals to change in concentration of reactant upon time. That's how we're doing, right? And also, change in concentration of reactant is nothing but the final concentration minus the initial concentration. Simple. Now let's try to find something. Let's try to find a relation. Over here, if you would see, what are we really looking at? Y is equals to C plus mx. If I keep time on the x-axis, this R naught becomes an intercept, and R the concentration of reactant on the y-axis. What's going to happen? The slope that I am looking at is going to be minus x. Minus means the slope is going to go down. So this is what we are looking at. On the x-axis, what are we really having? On the x-axis, we are actually having time, right? This value is R naught, this intercept. This on the y-axis is the concentration, y. And the slope, boys and girls, slope has a formula. dy by dx, right? Which is over here, which can be written as minus k over here. Do remember this. Is this clear? What is dy by dx over here? Pay attention. dy means change in concentration and dx means change in time, which I wrote it over here. K is equals to change in concentration, this is dy, upon change in time, this is dx. Right? So guys, write it down in your notebooks. Which is nothing but dy by dx also. Okay? Yes or no? Let me know in the chat. Is this clear? And if it is, like the video. And now let's move ahead. Over here we're doing a small question. So do not worry about the question. I am going to be with you in order to make sure that you actually do solve the questions correctly. Pay attention. Over here the question talks about the rate constant for a zero order in A is 0.03 molarity per second. What is this? The rate constant value. Which order are we talking about? If you can see the unit, it's anyhow the zero order. Okay? So now guys, pay attention. Over here, how long will it take? So they're talking about the time where the K value is given to you. For the initial concentration of A to fall from 0.1 till 0.075. This is the final one. This is the initial one. Correct? And what is the formula that we have seen? R is equals to R naught minus KT. This is what we have seen, right? Now let's do one thing. Now actually just take the R naught on the LHS. What is it going to be? R minus R naught is equals to minus KT. That's what it is. Now what are we really looking at? The T. Take minus K as well on the LHS. Take minus K on the LHS. Okay, we'll do that. Correct? This is time. So this is what we have to do in order to calculate the time. Let's see how many of you will be able to give me the correct answer. Come on, do this. Come on, come on, come on. Let's do this. What do you think? What is the value of R? This is R naught, initial. What is this? This is R. The K value given to you. Let's do this then. So I'm writing R naught first. I'm taking the minus sign inside. R naught 0.1 minus 0.075 upon 0.003. That is the value of time that you will get, and time is going to be in seconds. Why is that? Because the unit that we see in K is in seconds. So whatever answer you will be getting, it's going to be in seconds first of all. And now guys, what do you think? What is going to be the correct answer over here? Does anybody wants to solve? Come on. Even if you can't do this, why are you here? Come on, let me know. The answer over here. Yes, the correct answer to this question, it's absolutely going to be 8.33 seconds. Again the same thing, 0.1 minus 0.075 divided by 0.003. And that's how you get 8.33 seconds. If the question asks you, tell us the time in minutes or in hours, then you have to convert the seconds into minutes or hours. And that is what I'm not going to teach you over here. You just simply have to divide by 60 and 60 again, respectively. And now, let's talk about few more things. This is what we saw, right? Any reaction of zero order must obey this equation that we saw. Or, when we talk about this equation, we also talk about the same graph. Okay, so do remember this. And now over here, this shows that the concentration of reactant decreases linearly with time. See, the concentration of reaction or the reactant decreases linearly with time. Correct? The plot of R, the concentration versus time, will be straight line with the slope minus K is what I have told you. Okay, now, so what is the slope? It's minus K always for the zero order reaction. Do remember that. And now, over here we will be diving into the first order as well. Okay, but still, this is what I have told you. No matter how much concentration we change, the rate remains same. Because, pay attention, when we wrote for a zero order reaction, K is equals, R is equals to K, concentration of the reactant, I am going to write the reactant over here, R, raised to power 0. Then boys and girls, you should remember, this becomes 1, R is equals to K. By this you can write rate is independent of R. Do write this down. Is this clear? Come on, let me know. Is this clear? Yes, right? So this is the only reason when we are changing R, the concentration of R, the reactant's concentration, the rate does not change. And neither it's going to change with time. It's going to always remain constant. Always remain constant. Okay? And now let's talk about more. Over here, whenever we are actually going to talk about half-life. What is a half-life? Half-life means how much time do we need to spend, or does the reaction spend in order to make its the final concentration equals to its initial concentration. So let's say you took 10 molecules of reactant. How much time will it take to become 50? Or if you took 50 molecules, how much time will it take to become 25? You can talk about either molecules, either moles, or either the concentration. So don't worry about it. But that's how it is going to be. How much time? Because we're talking about kinetics, right? To have the final concentration half of initial concentration. This is what we're talking about. So let's do one thing. Let's keep R0 as R0, the initial concentration. Okay? Initial concentration. Let's keep R0, which is the R, which is the final concentration, but final concentration is nothing but R0 by 2. Yes or no? Now pay attention. What are we really going to talk about? Over here, what are we really looking at? This is the R, the final concentration, half of the R0. Now pay attention. Do you remember the formula? R minus R0 is equals to minus KT. This is the formula that we are going to use. Let's do this. Instead of R, what are we going to write? R0 by 2. Okay? Now let's take the 2 common. Let's simply start dividing. Over here, it's R0 minus 2 R0 by 2, which is equals to minus KT. This is what we can write, right? And now over here you should remember something is over here. What is it? Minus 1 correct? Now you should anyhow remember that is what we're talking about. It has to be half-life. It has to be half-life. Okay, so this is what we are actually looking at. What do you see over here? I'm simply removing 1 because anyhow there is no point of having that. Minus, so minus cancel. Initial concentration of reactant upon 2. Take K on the LHS. Is nothing but half-life. Where 1 by 2 is in the subscript. Where 1 by 2 is in the subscript. So do remember this. Do remember this. Is this clear, boys and girls? Let me know. Yes or no? Let me know. Okay? And now let's talk about the final equation. That is the final equation. You should remember half-life of a zero order reaction. This is for the zero order reaction. Totally depends upon the R0. Totally depends upon the R0. The initial concentration of the reactants. Okay? So do remember this. And now over here let's talk about the rate constants unit. We did this in the last class as well. Let's quickly revise it again. So as the K, we write it as, in the case of a zero order reaction, rate is equals to K. Rate has its own unit which never changes. Mole per liter per time. That is the case of, the unit of K. Mole per liter per time is the rate constant unit. Per time, it means per second, per minute, per hour, per day, per year, whatever. So do remember that. Okay. Now, let's move ahead. So there are some examples of zero order reaction. Simply like H2 and Cl2 in the presence of UV, getting us HCl gas. How will we write the rate law expression for this? Guys, pay attention. It's going to be rate is equals to the rate constant, concentration of H2 gas, concentration of Cl2 gas, raised to power m and n. Here m plus n is equals to 0. These powers, the sum of these powers are 0, is what you have to remember. And now, over here, pay attention. In the case of decomposition of N2O with hot platinum surface, so what are we really having? Again, pay attention. There is only one particular reactant. Rate is equals to rate constant N2O, concentration of N2O raised to power 0. That's how you will write the rate law expression for zero order reactions. Okay, amazing. Now over here, let's talk about few more. The decomposition of NH3 into N2 and the H2. Okay, so do remember this. Okay, give me a second. So what are we really going to write again? On the power, we are going to have the 0 value. Okay, and when we are going to talk about HI, converting them into H2 and I2, again the same thing. It's going to be rate is equals to rate constant and the concentration of HI raised to power 0. Okay. And now let's talk about the first order reaction. Let's talk about the first order reaction. A reaction is said to be the first order reaction when we can actually write something like rate is equals to K, concentration of reactant raised to power 1. The order of the reaction has to be 1. Correct? Now pay attention. So for this, what are we really going to try, right? So you should remember, in the case of first order reaction, this is how the graph has to be. It's going to be time, it has to be the concentration, and how is it going to be? It decreases exponentially. Okay, this is how it happens. Okay, so in such a scenario, what are we really going to write? In such a scenario, we will start with ln, natural log of the concentration, initial concentration minus the final concentration is equals to kT. All because the decrement is exponential, not regular. Over here, write this again. ln R naught minus ln R is equals to kT, right? And apart from this, just take what? The K on the LHS. But anyhow, this is ln A minus ln B, which can be written as ln A divided by B. So do that. ln R naught upon ln R is equals to kT. This is how it is, right? Now let's take either K or either T on the LHS. If you take K on the LHS, what's going to happen? 1 by K ln the initial concentration upon the final concentration is equals to time. Whenever you have to calculate time when the rate constant is given to you, and whenever you have to calculate the rate constant when time is given to you, simply take T on the other side, keep K on the same side. So this is what you have to remember. Guys, are you noting these equations down? Let me know. And now pay attention. We are also going to use the same formula to calculate the half-life as well. We will use the same formula to calculate the half-life as well. So do remember this. And also you can actually convert the natural log into log base 10. So what will exactly happen? When we were writing K is equals to ln r naught upon r, and this is how it is. But now what we are going to write, we are going to convert this into the log base 10. K is equals to 2.303 upon T log of the ratio R naught upon R. Okay, cool. Yes, Abhiram, you are absolutely late, but it's okay. Now, guys, pay attention. But anyhow, you have missed a lot. You have entirely missed the zero order reaction. Do not skip this video right now, but yeah, watch that recording. And now, guys, pay attention. Over here, how are we going to talk about the graph? So, guys, pay attention. Whenever we are going to write the same thing, log R on one side minus KT 2.303. That is going to be, see, this time is going to be the x. So minus KT upon 2.303 is going to be the m. This is what I'm marking as m. This one over here is mx. This x is t over here. This is y over here. This one is the c over here. Intercept, log of initial concentration. Okay, we will write this particular graph like this. Pay attention, boys and girls. This is the log of initial concentration. This is how the graph is coming up. Minus k upon 2.303 is the slope. What is on the y-axis? Time. What is on the y-axis? Log r, whatever the concentration is. So this is what you have to write. Okay? Do remember this. And now over here, this is, oh yeah, this is the graph. I was so busy writing everything over there, it's available over here. This is the intercept. C, what is on the x-axis? Time. What is the slope? Minus k upon 2.303. And the slope m. And this is going to be the y. So do remember this. Okay, yes, amazing. And now, boys and girls, pay attention. Over here, what are we really talking about? We have to talk about the calculation of half-life. Now, how are we going to do that? How are we going to do that? These microphones and the wires, I really wish I could have. I am simply going to buy a one which is going to be wireless now. So fed up of these wires. Now, guys, pay attention. Okay, give me a second. Wait. Okay, the chair is also not in the way. Okay, now guys, pay attention. What are we really looking at? So now if I actually write T is equals to log R naught upon R upon K, right? But over here there is 2.303, correct? On K. So now let's go with this. Pay attention. I'm writing half-life over here, which means 2.303 log upon K, but the initial concentration remains initial. The final concentration becomes half of initial. Correct? Now, just remember x upon x by 2 can be written as 2. Can we do that? X upon x by 2 can be written as 2. Right? So this is what we're doing over here. When we cancel these out, what are we really getting up over here? Half-life is equals to 2.303 log of 2 upon K. Log 2. What is log 2? What is log 2? Who knows the value of log 2? 0.3010. Now, just multiply 0.3010 by 2.303. You will get the answer 0.693 upon K. And here's the half-life. Now guys, do you see in this formula, there's nowhere that we can actually see the initial concentration of reactants. That means the half-life in the first order reaction is independent of the initial concentration that you use. Not in the case of zero order. If you put more, initial concentration, half-life becomes more. But in this case, no matter what particular value of initial concentration that you put, the half-life remains same. Okay? Is this clear to everybody? Come on, let me know. And now over here, let's talk about how can we really have a formula which can actually show us, a generic formula for half-life. So guys, pay attention. Now at T is equals to 0, when we didn't start the reaction, we had A0. At T is equals to this one half-life. Let's say one half-life, in order to make 100 molecules become 50, the time is 30 minutes. After 30 minutes, it became 50. After 60 minutes, twice the half-life, it became again 25. And after n number of times of the half-life, then what is going to be the formula? The formula over here is going to be at T is equals to n number of times, the concentration A of the particular reactant becomes A0 upon 2 raised to power n. If you keep the n value as 1, that means just one half-life passed away and the value becomes half of it, from 100 till 50. If you keep the n value 2, that means 30 minutes passed away and then again 30 minutes passed away. Then this value becomes 2. And instead of having 50, when we started with 100, your answer is going to be 25. That's how it is going to be. Okay. So this is the formula that you actually have to use whenever the question gives you n number of half-lives. So do write this down in your notebook. Okay. Is this clear to each and everybody? Come on, Vidya. Pay attention over here. You should be more focused on the concept and the formula. Okay. And now guys, pay attention. What are we really looking at? The same formula. A is equals to the concentration, final concentration is equals to the initial concentration upon 2 raised to power n. That's what you have to remember. Okay. And now we are also again going to talk about the unit of rate constant. So what are we really looking at? So whenever we talk about the rate, it's equals to the rate constant into the concentration of reactant raised to the power 1. What is the unit for the concentration? It's moles per liter. What is over here? Moles per liter per second. Correct? Oh, per second. Now moles per liter and moles per liter on the both the places cancel each other. What are we really having? Just per second or per time. So per second is the rate constants unit. Per minute, per hour, per day, per year, per month, whatever. That's what you have to remember. Okay? Is this clear to each and everybody? Now over here, let's talk about few questions. So now you have to be very much active over here. Calculate the half-life period of a first order reaction where the specific rate constant is. Think about it. So over here the specific rate constants are given to you. See, per second, per minute, per year. So ultimately we are all talking, these all the options are for the first order reaction. Even if the question doesn't write over here, you should know it. Okay. And now what is the formula that you will use? So half-life period. So the formula that anyhow you guys have to use is going to be 0.693 divided by K. So if you put the value of K in the A option, 0 in the A option, half-life is going to be equals to 0.693 upon 200. The value that you will get is going to be in seconds. The value over here for the half-life is going to be in minutes, The value of the half-life in the third case is going to be in years. So do remember this. Okay? Yes or no? Do remember this. Okay? The only formula that you have to use, and this is going to be the homework. This is the homework you actually have to, whosoever watches this video again later as well, you guys actually have to, let us know the values in the comment section. And yes, over here, I'll hide this. Let's do few more. Let's learn how to do this. For a first order reaction, calculate the ratio between the time taken to complete 3/4 of the reaction and the time taken in complete the half-life, of the reaction. Half of the reaction. So that means the half-life. To complete the reaction, 3/4 and half-life. So what will you do? First order reaction, right? So now guys, pay attention. Whenever we talk about 3/4 of the reaction getting complete, in this scenario, just remember that the R value is always equals to 1/4 of the initial value. So if you took 100 moles, they should become 25. This is where 75% of the reaction is complete. So do remember that. Okay, so 1/4 should be remaining. What is going to be the value? T 1/33/4. It is going to be 2.303. The rate constant remains constant. Log R naught upon R naught, which is going to be by 4. Right? This is 1. We're talking about the ratio, right? And now guys, write it again. Half-life is equals to 2.303 log on K, which is going to be R upon R naught upon R naught divided by 2. Now let's do it. Over here, this becomes log 4 and this becomes log 2. This log 4 can, 4 can be written as 2 raised by 2, and log 2 raised by 2 can also be written as 2 log 2. Correct? It's 2 log 2. Okay? Let's do this. Now ultimately, let's simply take the ratio, which is going to be like pay attention, boys and girls. 2.303, 2.303 getting cancelled. K and K getting cancelled. It's only about 2 into log 2 upon log 2. Just cancel both of these and you have the answer. But how, is this more easy? Yes. I'll tell you something. Just remember, whatever, see, if you take 100 moles and you make it 50, how much time? 1 half-life. And from 50 till 25, is this the 75% completion? Is this the 50% completion? Right? So how much time does it take to complete, to have a 75% completion? It's always, just add these, twice the half-life. It's always the twice the half-life in order to complete the reaction 3/4, 75%. Always remember that. I could have done this to you, for you guys in the starting, but I just wanted to tell you how mathematically we can calculate. The question talked about calculate, but yes, you can minimize, you can neglect this calculation and you can directly give the answer through that. But there had been times where the question will also ask you, what if the reaction is completed 99%? Then what will you do? You have to use this calculation. Okay? So today is a very quiet day. Yes, absolutely. I don't know why didn't the notification went to the students or what exactly happened. So, but that's okay. Anyhow, I'm going to record the session and obviously people will get it. Now, over here, the answer to this question is going to be 2. Okay? And some examples for the first order reaction. Yes, just remember over here we're talking about hydrogenation of ethane. over here C2H4 plus H2 giving you C2H6. Organic chemistry, right? What is C2H4? It's an alkene over here. It's an alkene. What are we doing? Reduction. We're providing more and more hydrogens. It's a reduction. Decomposition of nitrogen pentoxide. Decomposition of nitrogen pentoxide, N2O5. And decomposition of N2O5 is the most frequently asked reaction in chemical kinetics. 2 moles of NO2 and 1 mole of half mole of oxygen. That is also a first order reaction that we did. We practiced two questions in the previous class on the same reaction. Do remember this. And now over here, what are we really looking at? Pseudo first order reactions. So we're going to talk about pseudo first order reactions. The first one is hydrolysis of ester. What is a pseudo first order reaction? So ultimately, in the case of pseudo first order reaction, the rate of the reaction depends upon both the components. More than one reactant, but when one particular reactant is in too much excess, let's say you have 10 liters of water, 10 liters of water. You're simply putting up the esters or the sucrose in a very, very, very less quantity. Maybe 1 spoon in 10 liters. That is what we're talking about. So ultimately, then it totally depends upon the concentration of the one which is in lesser quantity, and hence it behaves like a pseudo first order reaction, because anyhow the concentration of the second reactant is not at all going to change in front of the first reactant. So do remember that. Okay. And over here, when these H2O are too much in excess, it clearly depends upon only the sucrose and the ester. And you should remember over here it's actually hydrolysis. So ester is getting converted into acetic acid and the alcohol. And similarly, in the case of sucrose, it's getting particularly broken down into glucose and fructose. H2O is in higher end quantity, hence the pseudo first order reaction. Okay? Now Sarvesh is also here. Amazing. Now guys, pay attention. Again, do you see something? I've told you, right? This particular reaction is going to be there a lot of times in the JEE examination as well, in a lot of previous questions as well. So now N2O5 giving you 2 moles of NO2 and half moles of O2. Okay? The initial concentration of N2O5. This is the one. Guys, what is this? R0. The initial concentration 1.24 into 10 raised to minus 2. And after 60 minutes, it became 0.2 into 10 raised to minus 2. That means what I see is, any of the powers are same. So from 1.24, it became 0.2. Correct? After 60 minutes, this is the time given to you guys. The question talks about calculate the rate constant. Now let's do this. Okay? The value of K comes out to be equals to 2.303 upon T log of R0 upon R. What is the initial concentration? Initial concentration comes out to be 1.24 and the final concentration comes out to be 0.2. I am simply cancelling out 10 raised to minus 2. Okay, I don't really care about it, but because when we are going to take the ratios, these numbers are going to get cancelled. Now over here, you just simply have to calculate the log. What is it going to be? What is it going to be? So now, if you would see, what are we really talking about is, let's remove the points. It will become easier. If I remove 1 decimal from here, it becomes 12.4. Correct? Divide 12.4 by 2, which is going to be equals to 6.2. Right? And you should remember over here what are we really having? We are having the T value as well, which is 60. Anyhow, the value that you are going to get for the K is going to be per minute from here, because the time of completion is in minutes. Time of completion is in minutes. Okay? Sir, echo ho raha hai? Is it? Nobody told me that today there is an echo. Okay, we'll see. After the class, I'll see the recording again and I'll try to fix it up. Okay? Come on, boys and girls. And now, pay attention. Come on, boys and girls, try to solve this one. Even if you want to make it easy, what you can really do is just try to calculate the log 6. Log 6 can be written as log 3 plus log 2. Try that one out. Log 3 plus log 2. Multiplied by 2.303. Divide by 60 and you'll get the answer. Do you remember the log 3 and the log 2 values? If not, you have to remember those. Okay. And now over here, what do you really get? You get the value log 3 plus log 2, which is 0.7924. The answer comes in per minute. 0.03 per minute. 0.03 per minute is going to be the correct answer. Echo is because speakers are reflected. There's only just one mic that I'm using. Give me a second. Give me a second. Exactly happened. Okay. Boys and girls, is this clear now? Wow. Why didn't you guys tell me before? That's so bad. Chalo. Is this clear? Okay, sir. Amazing. Give me a second. Okay. Maybe a kitten cut the wires. No, it didn't happen. Now is it working? Yes. Amazing. Chalo. And now let's calculate the half-life for the first order reaction in 60 minutes. For the half-life, 60 minutes. How long will it take to consume 90% of the reactant? Wow. So let's say I started with R0. What does it means when we are talking about 90% of the reactant? That means the leftover reactant is going to be just 10%. If I started with R0, the leftover should be 0.1 of R0. This is where I can say just 10% of the reactant is complete or is left, right? 90%, 0.9 of the initial concentration is gone. So do remember this. And now over here, how are we going to write? So over here, how will it take? How much time will it take? So the half-life is given to you. So first of all, calculate K value. K is going to be 0.693 upon 60. Right? It's a first order reaction. That's the reason we are using this formula. K value is known to you. Now, how much time is it going to take to complete a reaction by 90%? That means R0 upon R 0.1 upon the K value. K value comes out to be 0.693 upon 60. And just remember, these values go cancelled and just left with 1 upon 0.1, which can be written as log 10. And log 10 is nothing but 1. So what you really have to just calculate, T is equals to 2.303 into 60 upon 0.693. This is what you have to calculate. And the correct answer to this question comes out to be 300 minutes. That's how it is going to be. Okay. Yes. So this is how it is going to be. See, the value of K 0.693. You just simply are going to write log. You're simply going to get log 10, and that's how it is going to be. Okay. Do remember this. Clear? And this is where we are absolutely at the end of this class. Do make sure that you actually join these sessions as early as possible, because ultimately you should really remember that this is your time to make the change in your life, and you have to be regular when I am taking your classes on a regular basis. Okay? And yes, do practice more and more questions from chemical kinetics. If you want DPPs to solve, I will be sharing these DPPs in my Telegram channel. So do remember that. Okay, and we'll meet again in the next video. So stay tuned, and yes, let's take a goodbye right now. Stay healthy, good night, and let's meet again. And do not forget to subscribe the channel. Okay, bye bye, take care, tata, tata. Let's meet again tomorrow. Bye bye. Subscribe to the channel, it's very much important. Share the video. Bye bye.